All right, today we're going to dive deep into a protocol that honestly is quietly changing the game for how AI applications get built. It's called the Model Context Protocol, or MCP. And whether you're a developer deep in the trenches or just fascinated by where AI is going, you're going to want to understand this. It's truly foundational for what's coming next. So here's our game plan. We'll start with what we're calling the connector nightmare. It's the big problem that MCP is built to solve. Then we'll look at MCP as the solution, this sort of universal adapter. After that, we'll get our hands dirty and break down the protocol's anatomy and how it works step by step. And finally, we'll talk about the real-world limitations and what this all means for the road ahead. Let's jump. Okay, so first things first, let's talk about the problem, the connector nightmare. And trust me, it really is a nightmare. It gets right to the heart of the biggest challenge we face in making these incredibly powerful AI models, well, actually useful in the real world. And it all comes down to a really fundamental limitation in how they work. Which brings us to the question that every developer trying to build something cool with AI eventually asks themselves, why is this so hard? Why is it such a pain to connect these large language models to the live, real-time data and APIs? They need to be truly dynamic and autonomous. Well, the root of the problem is this. LLMs have what's called a static knowledge base. Think of it like a giant encyclopedia that was printed in, say, 2022. It's incredibly knowledgeable about everything up to that point, but it's frozen in time. The only way to update it is with a massive, expensive retraining. So it can't answer simple questions like, hey, what's the weather like outside right now? Or what's the price of Bitcoin at this exact second? To do anything useful, they need live, dynamic data. And yeah, things like RAG and tool calling are the best tools we have for that right now, but they introduce their own problems. And this is where the mess really begins. Let's say you just want to connect one LLM to one single API. Even that is a huge chore. For every single new service, a developer has to sit down and write custom, one-off code. You have to handle its specific authentication, figure out its weird data formats, deal with its error handling, and the resulting connection is incredibly brittle and just a total pain to maintain. But of course, you never have just one app and one API. That one-to-one problem just explodes when you try to scale it. You have M number of AI apps, and they all need to talk to N number of different APIs. What you end up with is this absolute tangled mess of point-to-point connections. It's a spaghetti architecture that is chaotic, impossible to scale, and a complete and utter maintenance nightmare. So how do we escape this integration chaos? Is there a better way? Yes, there is. This is where the Model Context Protocol comes in. It offers a really elegant solution by basically acting as a universal adapter for AI, turning that tangled mess into something clean, logical, and scalable. So, what is the Model Context Protocol exactly? At its core, it's just an open standard, a common language. It allows any system, whether it's a database or a web API, to provide context and tools to an AI model in a completely standardized way. It's basically creating a universal plug that any tool can use to connect to any AI. And the power of having a standard like this becomes obvious almost immediately. MCP takes that chaotic, impossible N-by-N connector problem and transforms it into this beautifully simple M+N architecture. Now, your apps and your tools only have to speak one language, MCP. All that chaos is just gone, replaced by an orderly, scalable system where everything can just talk to everything else. You know, Reed McGinley-Stemple had the perfect analogy for this. He said MCP is like USB-C for AI. And that just nails it, right? Think about how USB-C created this single universal standard that lets us connect all of our different devices with one cable. MCP does the exact same thing, but for AI models connecting to this huge universe of different tools and services. Okay, so we get the why. We see the value. Now let's pop the hood and get a little more technical. It's time to actually look at the anatomy of the protocol and meet the key players that make all of this work. In any MCP interaction, you've really got four main components. First up is the host. That's the AI application itself. Think of something like an AI coding assistant in your editor. That host runs an MCP client, which is basically a library that handles all the communication. Then on the other side, you have an MCP server. This is just a really lightweight wrapper you put in front of a tool, like the GitHub API. And finally, you have the tool itself, the actual function that the AI is going to call. So we have our four components, the host, the client, the server, and the tool. Now let's see how they all work together in a beautiful little dance. We're going to trace a typical request as it flows through the whole MCP workflow, all the way from a user's question to the final answer. The whole process really breaks down into 5 simple steps. First, a user types a query into the host application. Then the MCP client on that host reaches out to a server and asks, hey, what tools do you have available? Based on the user's query, the LLM then intelligently picks the right tool and figures out the parameters to use. The client then makes the call, the server runs the tool, and sends back a response. And finally, the host takes that response and gives the user their final context-aware answer. And here, we can see that entire flow in action. The user's query kicks everything off over on the left. That triggers the client to ask the server for a list of its tools. That's step 2. Then, the LLM makes a decision in step 3, picking the perfect tool for the job. Step 4 is the actual execution. The client calls the tool and gets a result back. And boom, step 5, that rich, context-aware answer gets delivered right back to the user. It's a clean, logical, and totally repeatable cycle. Now, MCP is incredibly powerful, but let's be real for a second. It's not a silver bullet. It's important to talk about some of the current limitations and what they actually mean for developers who are building with this today. This is all about the realities of where we are now and the road ahead. One of the biggest realities for any AI developer is the very limited context window we have to work with on these models. And this is where a simple best practice can make a world of difference. See, most APIs return data in JSON, which is super verbose and just token inefficient. It's so chatty. But look at the same data formatted as CSV. It can use half as many tokens. That's a huge optimization that can prevent a tool's output from completely blowing up the model's context. So let's just quickly summarize the key constraints for developers right now. First, AI agents. They start to get confused when you give them a giant list of tools to choose from. They just don't handle it well yet. Second, like we just saw, a poorly designed API can eat up an agent's context window in a heartbeat. And third, and this is maybe the most important one, for tools to be really effective, they have to be designed to be AI native, flexible and intuitive for a model to use, not just a rigid wrapper around some old API. And this all points to one crucial takeaway for developers. You can't just slap a wrapper on your existing APIs and call it a day. That's not going to work. Building great tools for AI requires a totally new way of thinking. You have to design flexible AI-native tools from the ground up, keeping the agent's unique strengths and weaknesses in mind from the very beginning. And this brings us to a final, really interesting question to think about. Is the future of AI just about a race to build bigger and better models? Or is it maybe just as much about building smarter tools and foundational protocols, like MCP, that empower the incredible models we already have to interact with the world in more powerful and meaningful ways? That's something to chew on. Thanks for watching.